look at the thermometer reading how it increases when it comes in contact with a hot substance. This is due to the expansion of mercury when heated. We have already seen that matter is classified into three various types, that is solids, liquids and gases. All these substances also expand on heating. Let us check them one by one. Let us first perform an activity to show that solids expand on heating. Let us take a metallic ball as shown and a metal ring through which the ball can just pass at room temperature. Now heat the metal ball over a flame for a few minutes. You will be surprised to see that after heating the ball, it does not pass through the ring. The ball size increases. Now allow the ball to cool down to room temperature. If we again try to pass the ball, it easily passes at room temperature. This means the metallic ball on heating, its size increases so it does not pass through the ring. This increase of size of the solid on heating is called expansion. So we can conclude that solids expand on heating. Now let us perform another activity to show the expansion of liquids. Take a round bottomed flask as shown here. Let's fill with colored water up to its neck. Insert a long capillary tube in single holed rubber cork and fit it to the neck of the round bottomed flask. Place the entire apparatus on a tripod for heating. Mark the positions of the water level in the capillary, say P1. Now heat the round bottom flask for a few minutes. You will observe that initially the water level decreases, say P2, and on further heating the water level increases, say P3. The initial decrease of water level is due to the expansion of the container, that is from P1 to P2. The liquid starts expanding only from position P2. Thus, the actual expansion of liquid is equal to P2 to P3. P1 to P3 is called the apparent expansion of liquid. Thus, real expansion of liquid is equal to the expansion of the container plus the apparent expansion. That is, P2 to P3 is equal to P1 to P2 plus P1 to P3. Now, let us do one more activity to show that gases expand on heating. We need a long capillary tube CT as shown and trap a few drops of colored water A in between the capillary tube. Insert the capillary tube in a single hole rubber cork C and fit it to the empty, that is air filled round bottomed flask F as shown. The gap between the cork and the flask may be sealed by using wax. The apparatus is fixed on a stand S as shown. Now warm the round bottomed flask with a spirit lamp H as shown. Look how the colored liquid moves upward B on heating and moves downward, that is A, on cooling. This is due to the expansion of the air G inside the round bottom flask on heating. On heating, the expanded air of the flask pushes the trapped liquid up in the capillary tube, and similarly on cooling it contracts. The atmospheric pressure pushes the colored liquid down in the capillary. So, gases expand on heating. So, here we can notice that gases expand larger compared to liquids. The expansion of the container in this case can be neglected. So, from all these three activities, we can conclude that all matters expand on heating.